Wonderful. All right, so we are going to get started, kicking off our afternoon. And we're starting with Chris here. He's a staff engineer at Custom Inc. He's got his master's in computer science from RubyNation. And he loves flying drones, 3D printing, and riding monorails. And he helps organize Ruby Loco. You might remember that name from Sam's talk earlier. And is a host of Ruby 5. And he's going to tell us where services come from. So give it up for Chris.
Yes, okay. Thank you. Thanks for coming back after lunch. Let's talk about where services come from. I'm Chris Marr. I'm a staff engineer at Custom Inc. I'm also a host on Ruby 5. And a lot of times on my episodes, you might hear me drop a few Vanilla Ice jokes. Most people don't get them. But last year, I was fortunate enough to be invited to RubyConf, and I was all excited because I had a nice Vanilla Ice joke about how engineers solve problems. And I dropped the Vanilla Ice joke, and it went to crickets. Nobody got it. And I came home, and I told my wife, I was like, I took my Vanilla Ice joke. No one laughed. She's like, when are you going to stop this? And I was like, I don't know. But I do know that at Custom Inc. we print a lot of T-shirts. Everyone's probably wearing it or has a Custom Inc. T-shirt in their house. This year, we're expecting to print about 30 million T-shirts. And 30 million T-shirts is a lot of T-shirts. If I were to take those T-shirts and go tail to collar and line them up, it's about over 12,000 miles. That would take you from the North Pole to the South Pole. Okay. And that's a lot. And how many a day? So we're doing about 82,000 a day. That means for every single person in MetLife Stadium, we're printing enough shirts to put a shirt on every single person on every single day. And to do that, we're serving about 40 million pages a day and about 200,000 users visiting our site. Okay. And we do this with a monorail. We ride a monorail. This is great. We've been doing this for over 10 years. We've been riding the monorail since 1.114, and we've been continuously upgrading it. I went back into GitHub and found our initial commit, and it was in July 25th, 2006. This is a full year before the first iPhone came out. One thing that was interesting when you read the initial description of what models were, it says they're smart domain objects that hold business logic and they persist to the database. So from the beginning, the models had two responsibilities. The word domain gets thrown around a lot. But I like to think of the domain as your business domain and the objects that serve that business capability. A lot of times you shorten it to just domain, but that's what we're talking about when we say business domain. And they represent your model. And there's two ways that people are structuring their domains these days. Monoliths and microservices. The monolith you can think of as a single process application, a single Rails application. It might be running on multiple servers, but it's pretty much a single process on a single server. Where a microservices is when you start to split up and you think about making your application into a network-based application. It's all very dependent on network costs. I said we ride a monorail. Monorail is just a nickname for a monolithic system. Single process, single Rails application. From the beginning, Rails wants your entire business domain. And once it collapses into the Rails application, all your domain lives in app models. And if you follow this, it's wonderful. Living the monolithic life is easy. It's easy to understand. All your code's living in app models, all your code's in the same application, and all your domain is in one place. You get easy database transactions. You don't even think about it, but you get easy database transactions all the time. You get easy deployments. You have a single repository. You can use Capistrano to push it out. Super easy to cross boundaries. If you're working over here in this domain on these models, and you need a little bit of logic over in this domain, you just reach right over, load that model, add a quick method to it, or call that method. No problem to cross those boundaries. But what starts to happen is your models begin to have inappropriate intimacy. And that's a code smell. And without the strong boundaries in your application, your domain logic and your models start to become coupled, and it becomes very hard to make change over time. But there's other benefits of the monolith. It's easy to test everything. All your tests are in one big application. And there's a huge benefit, because when you start running your test, you get about 40 minutes of free time to go do something while your tests are running. Upgrades can be hard in the monolith. You heard the great talk by Prodimus yesterday talking about all the cool Rails 5 features coming. And we're looking forward to using those in about 3 to 4 years when we can finally get to Rails 5. But the insidious problem that we're dealing with is that it's hard to maintain boundaries in a single application inside a monolith. Every part of your business begins to know about every other part of your business. And this causes software entropy. So what happens is when you get started and you work on your monolith, it's easy to make change. You're moving really fast. But over time, your models become more entangled. And over time, it becomes more difficult to make change. And this is mostly because most Rails apps have weak boundaries between their domains. And for all the benefits of the monolith, there is another way that's developed, which is the microservices. Microservices split your business domain into a suite of small services. Each service is a full stack owning the data that's part of that domain. And they're using a lightweight communication protocol like HTTP to communicate between these services. Now, 12 years ago, I was giving talks, and we were always talking about service-oriented architectures. And those are different than the microservices of today. Back then, we had the enterprise service bus, and this was termed as the smart pipe and the dumb endpoint. So your endpoints were kind of dumb. So you would take something from your portal, you would submit some XML to the pipe would use all the XSLT, that's where all this technology started coming from. You'd plug into your B2B, you'd send it to a database, and after a while, there was so much logic in the enterprise service bus that no one understood really what was happening. And so microservices is kind of a revolt from that movement. And it's the idea of smart endpoints and a dumb pipe, HTTP. But microservices are hard. And if they're so cool, why is it hard to do microservices? Well, you just need to extract all your domains into services, sprinkle a little HTTP around, and you can be like all the cool companies that are talking about this stuff like Netflix, Amazon, and Spotify. But it's not so easy, especially for us that's been riding the monorails for a long time. This is a great tweet. If you have a poorly structured monolith, would you like a poorly structured set of microservices? If you don't have clear domain boundaries, it's almost impossible to cleanly break into microservices. If you don't get your domains and boundaries correct, you're just making a mess. But building a monorail should be easy. Rails gives you two objects, right? Controllers and models. It should be easy to do object-oriented programming. But if you could maintain discipline and maintain your boundaries between your domains, it wouldn't be a problem. But most people don't get it right. And when they get to when they break out into microservices, they're just multiplying their problems that they're experiencing in their monolith. And actually, it does the reverse of the goal, and it makes change even harder because now you're dealing with all these poorly structured microservices. So let's take a step back and talk about what a service is. A typical service refers to a set of objects or architecture that you communicate with an API. It doesn't say remote. It gets conflated that everyone thinks when you talk about service, you're talking about a remote service. It's not necessarily a remote service. It's just an extension of object-oriented encapsulation, except you're grouping a bunch of objects together and you're communicating them, and you have an API contract on how to communicate with these objects. The pro tip that you'll see is that I'm trying to emphasize that we need strong domain boundaries, whether you're in a monolith or you're in microservices. Having a strong boundary around the objects that perform business functionality and understanding how those objects within that domain work together and keeping control of the messages coming into the domain. But let's go back. So a model is a smart domain object. It captures your business logic and persists to the database from the very beginning of Rails 1. So let's look at an example. We create a model, an order. The model has many items. Very common. Nothing very exciting there. But you get a business requirement in. Okay, every time an order comes in, we'd like to track statistics for these orders that are coming in. Okay, we'll just create a new model called statistics, has a couple attributes. Then we go, what everybody does, you go to the after create callback, you say update statistics, create a private method, update statistics, and you couple the model to this order of statistics, and you're creating the statistics right there. Everyone does this all day long. It's nice. The after create's in the transaction. But you've coupled those two models together. This is the start of the coupling. We all learn when we first learn object-oriented programming that the single responsibility principle, that you should only have one responsibility within your class. And we've already added two responsibilities to that order. It's keeping the business logic persisting to the database, and now we've added the idea that it has to also track statistics. A good rule of thumb is that callbacks should only modify the internal state of your model and not actually be coupled to another model. So if we do this, this is what everyone does, and eventually you get more and more requirements. Maybe you're going to now get a new requirement that says we don't want internal orders to save statistics. External orders, customers coming in, we'd like to have the statistics, but internal orders, we don't want to do that. So how do you fix that? Well, in Rails 5, they fixed this. They added the suppress method. So now I have an internal orders controller. On the create, I say statistics.suppress, and anything within that block, any save to a statistics model will get ignored. And that's great. So now I can just say order create. I don't have to create the statistics. I meet our business requirement. But over time, you might get more requirements. So now we add an after create method for notifications. We add an after create method for order mailer. Doing all the kind of things that we all do. So that's easy. You just multiply your blocks. You can have 3 blocks in your internal order controller. Suppress it all. Create your order. There are some alternatives to this. The mantra that we've been following for a few years now is the idea of fat models and skinny controllers. Push all your logic down to the models. Keep your controllers kind of dumb. But there's no reason you couldn't, for the regular orders controller, pull it out, put the order create there, and have a statistics.create. But you're coupling those 2 lines together, so anytime you create a order, now you have to also copy that second line. And that's kind of a code smell. We don't really want to do that. But it is an alternative to coupling your models together. We can do a little better. There's a great pattern called the interactor pattern. And the interactor pattern, sometimes they're called service objects, is a great way to encapsulate some of this logic. In this case, I'm going to create a plain old Ruby object called order creator. It's going to open an order, it's going to take my params from my controller, it's going to create an order transaction, it's going to create my order, create the statistics, and then return the resulting order. Everything's nice and encapsulated in here. And go back to my orders controller, and then I can call my order creator new, call order params. Sounds like an amazing idea, right? This is not such a new idea. Back in 1994, when the Gang of Four book came out, in design patterns, this was the command pattern. This was 22 years ago. Talk about iPhone, back then we were rocking pagers. But this is an old pattern, but still a great idea. Now, I love Rails. We all love Rails. We all love the conventions in Rails. But one thing that Rails doesn't give us is a convention of what to call the directory of where to put these plain old Ruby objects. I like app services. But I tried to bring this into our team, and I've heard of other people bringing it into their teams, and no one can actually agree on what to name this one directory or where to put these kinds of things. So most people end up dumping them in their app models directory. But the big open source Rails app discourse, they chose to use app services. And Pro Life is great. They're easy to test. They're easy to mock. There's no database required. If you use the call method, then you can mock them with a proc. It's great. It's very easy to test and use these PORAs. And naming them is fun. I have the order creator, the email extractor, the account terminator. But what we're really doing here is we're using a model or an object to create a boundary around some logic. There's other ways to create these boundaries as well. Let's say Rails has the idea of namespace boundaries, which is wrapping all your domain models into a namespace. In this case, maybe statistics, I'm starting to recognize that that's growing. That's a growing domain. And I wrap it around a module I'm calling reporting. And then I'm going to put all my domain objects inside this lightweight boundary. And I'm already thinking, like, well, maybe this kind of namespace could eventually be a service, a reporting service. So you put that in your app models, and it's a lightweight boundary, but people can still come in and break the boundary and come in and start talking to your domain models. So now that if you need to mature and strengthen that boundary, you can move them to an unbuilt gem. Gems don't have to be remote. They don't have to be pulled down from Ruby gems or even pulled down from GitHub. You can actually put a gem inside your lib directory. You create your gem structure, and then you can use a path directive in your gem file to access that gem and bring it in. And it's a pretty clear boundary. This is a gem. This is a gem that lives in lib. Don't reach into here. It has a nice boundary around it. If you need to have more things into that gem, like assets, controllers, routes, well, Gregory gave a great talk yesterday on Rails engine, so you can upgrade that gem to a Rails engine. But what you need to start, as you start developing these boundaries, you need to start thinking, who owns the business domain? As the boundaries are created, identify who owns these capabilities that are within these boundaries. And those owners will eventually be the ones who maintain those boundaries. Owners provide care and feeding to these domain objects. Let's see. As if you say everybody owns the monolithic application, and everyone cares about it, you're actually saying nobody owns the application. Because what happens is, you're over here working on a feature, you have a timeline, you have to get it done, and you need a little bit of logic over here in this domain on these models. You're just going to pop over, add some logic, not to really think about how it fits within the scope of that model, come back over here and finish your feature and get it deployed. Owners watch the boundaries. They carefully watch the boundaries and the messages coming in. As you establish these boundaries in your application, the microservices will eventually evolve out of the domains developed in the monoliths. Owners maintain the domain, and as the team starts to become well established of the ownership of this domain, they might decide to eventually evolve that domain independently from the monolith. And that's where they start thinking about doing a microservice. And when you do a microservice, you're doing a strong decoupling of your domain from your monolith. This is the strongest boundary domain. You're saying all this code lives over here in this new application, this new service, and is separate from the monolith. That's easy. So there's a couple tips on doing this. When you do that, you want to move all your database tables as well. So when you move and extract the domain logic, you also have to be willing to extract all the domain, the data that's part of that domain. The new microservice owns that domain. It's a full stack. And then you have to go back to your monolith and force your monolith to use that service to not use the tables anymore. The monolith cannot have direct access to those tables because you've moved the ownership of those tables to the new service. Most people are using a lightweight HTTP API to communicate. John did a great talk on HTTP today. But we should know this. We do web. We got this. It's no problem. And of course, we're solving some problems, but now we get great things like latency and timeouts. When we're in a monolith, every method call you make, it's almost guaranteed that it's going to happen. It's going to execute. Now that we've moved logic over into the microservice, every call could fail. Every call could time out, or it could just take a really long time. Instead of monitoring one monolithic application, now you have to monitor 2 applications. If the service goes down, most likely your monolith is not going to be operating at 100%. You get double deployment fun. Now you have to coordinate changes between your microservice and your monolith. You have multiple owners, multiple services, multiple teams that are going to have to start communicating together. But now you're microservices. And so you do get a lot of benefits from making that and dealing with that pain. You're in separate processes. The microservice can scale separately from the monolith. So if you need a lot more horsepower, you can just scale it out horizontally. You have super strong boundary. You don't have to really worry about people crossing your boundaries. And in the microservice, you've reduced the test service. So all you're doing is testing the domain and the logic that's owned by that microservice. If you were following that interactor pattern that we talked about before, if you extracted all the reporting into a service, now I can use dependency injection. And in my initialize method, I'm going to pass in the reporting service. And then you'll see in my transaction there, I order create, then I call over to reporting service and create statistic. More experienced developers in the crowd, I'm sure, are looking at that and they're feeling the pain. Everyone see what the problem is here? I'm opening an order transaction, so I'm grabbing a connection to my database. I'm making one change to the database with my order create, but now I'm waiting on an HTTP call to call over to another service and wait for it to come back, and I'm holding onto that database transaction. There's a lot of ways around that, but that's kind of the idea of the things you have to start worrying about. You don't have simple calls to the database anymore. Now you have to start thinking about HTTP calls. At Custom Inc., we have fire teams, and we've broken our teams up into these full stack teams. A lot of companies used to divide their teams up by technology. You'd have the front end team, you'd have like the Rails team, you'd have like a database team. But when you start thinking about microservice, you need to think about a full stack team because they're going to own a business capability and you have to be able to deliver that full capability. An example of something that we've been talking about recently is that we have our monolith. We love the monolith, but we realized like our catalog was not growing fast enough. We needed to be able to iterate on the catalog faster than the monolith was letting us. So we identified the team ownership of this monolith. First thing we're going to do is we're going to create a new product service, and we're going to move that domain around product into a new service that's owned by this specific fire team. After we do that, they can come back along and they can move the catalog into another service or another application that's using the service. But what we've done is we've given complete ownership to this fire team, so now they can change the catalog and change the product at the speed they want. the microservice can now start to grow independently of the monolith. And the team who owns it, they can solve the business problems in the best way possible. They can scale horizontally, they can use other languages, they can bring in Elixir if that's the best way to solve the problem. They just have to maintain an HTTP API contract with the monolith. And this sounds great. Why can't we just start with microservices if this is the end goal? The problem is the path is not always clear. Do not start by prematurely creating your microservices. When you begin an application, you do not understand the business domain, and you will get your boundaries wrong. I can almost guarantee it. And you lose the early speed benefits of working in a monolith. And most people who start with microservices, they actually end up collapsing back into a monolith so that they can progress and then eventually break back out. So what you want to do is you want to listen to your code. Your code will identify your domains. Boundaries will start to develop over time, and you start to identify ownership. Think about how you can break into teams. We call them fire teams. Spotify calls them squads. Amazon has a great term. They call them the 2 pizza teams. This is the teams, the ownership teams are the size that 2 pizzas can. They only need 2 pizzas to eat. The team may break out into a microservice, but if they do, they're establishing an API contract that they're keeping with the other teams. So when the other teams need something like the product data, the owner team is maintaining the API contract of what's coming in. They understand what's coming in. A lot of people talk about Conway's law, and this is what happens is that your software architecture starts to reflect your team structure. So as you break out into 2 teams of ownership or 3 teams, then you'll start to notice that there'll be 2 or 3 microservices that are kind of owned by these domains, these teams. So the best bit of advice I can give you is to love your monolith. Start with your monolith, start with your Rails application, embrace the benefits you get from being in a monolith. Rails wants to be a monolith. Follow good object-oriented design. Use more than 2 objects to solve problems. Think about the single responsibility principle. Plain old Ruby objects are awesome, and they're a lot of fun. Don't be scared to create objects. Avoid tight coupling in your models. Start thinking about this from the beginning if these 2 models really need to know about each other. And maintain your domain boundaries. Use namespacing, unbuilt gems, and before breaking into a microservice, feel the pain. Pain is good. Domains will let you know when they're ready to bust out of the application. Maybe it becomes too hard to change this code. Or maybe a single it's eating up all your process and you need to move it to a separate process. Let the services evolve. Remember, you're not Amazon, Netflix, or Spotify. If you are, ignore this talk. But if you do research microservices, most of the good talks are by guys at Amazon, Netflix, and Spotify. But Spotify, they have 600 developers working on 800 plus microservices. They're solving different problems than we're solving. Embrace the monolith. DHH has a great write-up about monoliths, the philosophy of Rails, but it's the philosophy of monoliths, and enjoy it as long as you can. Thank you.